Welcome to this demonstration video. I'm going to show you briefly how to use the response plan analyzer, replan, to create and analyze aerosolized anthrax response plans. Now I've already pulled up a scenario, and this particular scenario is the 49 county region in north central Texas known as DSHS region 2/3. So I can see here in the interactive map interface these 49 counties. I have a list of facilities that are already loaded into the system, including everything from stadiums, high schools, places of worship, nursing homes, so on and so forth. Basically, any types of facilities that it could be useful to understand where they are in relation to pods, or facilities that may serve as candidate locations to host pods. These same facilities are also available through the Facilities tab, where we can actually add additional facilities if there are more in your jurisdiction than is reflected in the replan system. So to get started, we're going to go to the info panel, and here replan will give us an overview of the population and the number of occupied households in this particular jurisdiction. So here we could see for region 2-3, we have a population of about 8.1 million, but really for an aerosolized anthrax response plan, we're going to want to look at using the CDC's head of household approach, where you have one person from each household visiting a pod location to receive medications for the entire household. So 2.8 million people is what we'd expect to walk through the pods in this region. So now from here, if you have existing pod plans, you can easily import them as CSV files. But for the sake of this demonstration, I'm going to show you how powerful replan is at actually creating response plans even from scratch. So what we have here is called the resource analyzer. We're going to start off by selecting households, since we're doing aerosolized anthrax and using a head of household approach. Next, we're going to select an amount of time it takes to dispense to a single individual at a single dispensing lane. So I'm going to go ahead and select 180 for 3 minutes. Next, we are asked about how many dispensing lanes we would expect to see in each pod. Now, none of the pods are going to be exactly the same. However, this is just asking for a rough estimate. How many lanes do you envision, on average, being in each pod? So we'll leave that at 15 for now. Finally, we have a total number of lanes that are needed across this entire region. Now, given just the information from these three slider tools, as well as the fact that we're planning on the basis of households, we can calculate a plan execution time for medical countermeasures dispensing. So you'll notice as I drag this slider up, the plan execution time falls and the total number of pods increases. So for aerosolized anthrax, I probably want to be somewhere in the 36-hour range just for dispensing, since out of the 48 hours mandated by CRI, some of that time needs to be dedicated towards distribution. So let me move this up until here we go, that's pretty close. So we'll need 268 pods across this region to be able to serve the population. Now the next thing I'm going to do is I need to figure out, now that I know how many pods I need to figure out where to place those pods. Across a region as large as this, I'm going to have thousands of different facility types, including schools, pharmacies, stadiums, so on and so forth. How do I choose 268 of those to serve my population best? Well, obviously we want to have more pod facilities where we have more population. Therefore, you're basically matching the number of resources you're placing in a region to the demand in that region based on the population distribution. So what I'm doing now is I'm actually dividing this 49 county region up into 268 pieces, such that each one of these pieces will be approximately the same size in terms of numbers of households. Now this takes just a minute because it's a fairly complex process to run, but when it's done, I'll be able to see basically how the population distribution varies across this region. The smaller pieces, the smaller partitions, will represent areas that are much more densely populated, whereas the larger partitions will represent areas that are much more sparsely populated. So if I can place a pod location in each one of these areas, I've then achieved my goal of actually distributing pods across the region according to population distribution. As I mentioned, this is a fairly complex process, and I'm not doing any editing to this video, so you're seeing how this runs in actuality. Of course, if you're doing this on just one or two counties, a much smaller jurisdiction, this comes back very quickly. But this jurisdiction, if you're not familiar with North Texas, is several hundred miles across. So this is a fairly large area. And here we go. So now you can see these dark boundaries are showing the partitions that it just created. If I go into the pod manager, I can look at the household distribution, and I see that they're almost uniform. Now, they're not exactly uniform. They can't be, because what I'm doing is I'm respecting the census population block boundaries. The population blocks I'm using are actually census block groups. So I can't just add one more person at a time to make everything uniform. I have to add an entire block group at a time. That's why we have this variation. But now going back to the map, since I know that each one of these partitions in the dark black, with the dark black boundaries here, represents the same number of households, I can see there's a lot fewer households per area here than there are over here, but the partitions are so small and so close together, I really have to zoom in to be able to see them. Now if I go back to the pod manager, you'll notice that each one of these pods has just a name: uniform pod 1, uniform pod 2, so on and so forth. If I click on any one of them, it'll zoom in to that location on the map. Now this doesn't really tell me where this pod is in terms of what facilities are there, unless I start turning on and off facilities, but that's a fairly lengthy process. Let's just take a look at Google Earth to see what's there. So here this deep links me directly into Google Earth, and I could see that I'm more or less just in the middle of a field. So that doesn't help me much at all. Consequently, what I need to do is I need to actually place these pods at facilities that exist in this jurisdiction that are capable of hosting them. Because right now, the system is just recommended areas that are central to each one of these partitions. Matter of fact, it selected the geometric centroid of each partition. So I'm going to go into my auto placing pods tool, and here I have a number of different candidate locations. Let's say I want to pick from high schools, but if there's no high school nearby, maybe I want to do stadiums. Let's put stadiums on top. So stadiums, and then high schools, maybe universities, middle schools. We'll fall back on places of worship if there's nothing else available here. I'll click auto place. This only takes a moment. There we go, and now that it's done, when I go back into the pod manager, I see that these pods actually have names and addresses associated with them. So they're actual facility locations now. But one problem that's cropped up is that look at some of these pod locations. They're now on the very edges of these partitions. So these partitions don't serve as catchment areas very well, because what's to keep someone that lives here from just crossing this imaginary boundary here instead of going over here? Now, keep in mind we've already placed our pods according to population density distribution, which is what our real goal was in doing this. So it's okay if we redraw these boundary lines to come up with better catchment areas, since we've already got what we were going after. Now when we redraw the boundary lines, we're going to lose our uniform household distribution, but that's okay. We'll be able to solve that in a moment. So I'm going to assign every census block group to the closest pod to it. And we'll see these dark black boundaries move just a little bit here and there. All right, so now that's done. Let's go back into the pod manager and I'll see now this is nowhere near uniform. It's not terrible, but it's nowhere near uniform like it was before. If I go into my times, I can see that I've got this red bar, which is placed basically at 36 hours, according to what I'd selected using the tool of the sliders, the resource analyzer. And I have some of these pods can beat this by a tremendous number of hours, and other pods exceed it. Well, the reason for this is that these pods that can beat the time have a much smaller population they need to serve than these pods that exceed the time. Nonetheless, all of these pods have been given the same number of dispensing lanes, so they're all given the same resources, even though some of them down here don't need it, and some of them need even more. So what I really need to do is I need to resolve these issues. So I'm going to resolve the deficit according to households. And what the system does is for each pod, it calculates the minimum number of dispensing lanes required to meet or beat this 36-hour timeline that we specified using the slider tool. So now each pod has the number of lanes it needs to actually complete dispensing in this time. In the table down below where I have all the pods, I can click on the number of lanes here, and I can see the largest pod now needs 19 lanes. The smallest one, the largest pod, here it is over here, 35 lanes, and the smallest one is 19 lanes. I'm sorry, not 19, 14. 3 lanes, there we go. I don't know what I clicked. So it could be the case that you decide that this pod is just too small. We might as well get rid of it and allocate resources elsewhere. Whereas this pod that's very large, you may decide that there's no way to fit 35 dispensing lanes in this pod, and therefore we may click on that pod and start looking for other facilities that are nearby, where we could potentially have a second pod location to offload some of this burden. Now, once you have your set of pods, the next step is to actually look at special, vulnerable, and at-risk populations. Now, it's insufficient just to know that vulnerabilities exist. What we really need to know is what types of vulnerabilities exist, and more specifically, how many people there are in each potential vulnerability subgroup and we divide these subgroups according to resource needs. So it's not really that useful for us to know that there are X number of people that don't speak English in this area. What is useful for us to know is there are X number of people that don't speak English in a particular area, and this many of them do speak Spanish, versus this many speak Vietnamese, versus this many speak Korean, versus that many speak Arabic. Now you have actionable information that you can use to make resource allocation and distribution decisions. The same goes for other types of vulnerability analysis, other types of vulnerabilities. whether we talk about age, the very young pediatric patients versus the elderly patients, or we talk about other types of disabilities such as um, hearing, visual, cognitive, or even if we talk about transportation issues where people potentially don't have access to a vehicle in their households and they live very far away from a pod. So in this example, we're going to do language first. So here we'll select the Vietnamese population. Now, we're really viewing two maps here. This bottom map with the different colors of blue is showing more or less the raw data as we get it from the Census Bureau. It's depicting the counts per census tract in this case. This gives you as a planner an idea of how this population is distributed across your region. But truly what you need is how this maps to the individual pod locations. It's more interesting if we zoom into this denser area in the DFW Metroplex for a moment. So here we have the pod locations. The pod markers have been replaced with markers that look like thermometers. Where green means that there's very few, partially red, even more red, and all the way red gradually increase the number of this special population. So now looking at this area, if you only had a handful of Vietnamese speakers that you could use at your pod locations, you can easily figure out where to put them. You're obviously going to want to put one here, 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 maybe one here. And then if you had any left, you can choose maybe over here somewhere. Now, you don't have to look at this data just on the map. You could potentially look at it on the bar chart, or we have a table that has all of the different languages that we have in the system per pod. And this table can either be explored in Replan, or it can be exported as a CSV file that would open up either in ArcGIS or in Microsoft Excel. So it puts the data right there at your fingertips. You don't have to use an external program, but if you would like to, it's right here. Now this is the Vietnamese speaking population that doesn't speak English well. What about the Chinese? We see the patterns change a little bit. What about Korean? Arabic? So you can really see the idea that having a needs-based vulnerability analysis tool is critical to the successful implementation of this type of response plan. Because just knowing that there are people that don't speak English is not enough. That doesn't tell you what you need to be able to serve these people. You need to be able to understand what resources these particular populations actually need. So now let's go to age. Here we can see the pediatric population, the elderly population, or just the minors. And again, we have a similar bar chart interface along with a data table that can be exported. We have disability status. We have ambulatory disability, hearing, vision, and again we have all this data at your fingertips here. Finally, we have transportation. So for transportation, it's a little different than the other ones, because what we're really looking at here, as I mentioned before, it's households that don't have a private vehicle. So it's really vehicle ownership per household. So this map, in the same type of way as the other vulnerability maps we're showing, gives you the raw data in the background for these census tracts, as well as a mapping of these census tracts to the pod locations. But take a look at maybe this pod location. We can see that these darker colors mean more households that don't have access to a vehicle. But a lot of these census tracts that are the darker colors of blue are right next to the pod. You're not really vulnerable if you live across the street from the pod just because you don't have access to a vehicle. You could walk across the street. Now, could you walk a block, 2 blocks, half a mile, a mile? Where's that cutoff where it becomes infeasible for you to walk to receive life-saving medications for yourself and your family? Well, I'm not going to answer that question, so we'll leave that up to you. So I'm going to say let's keep our existing pods. We're not going to consider public transit. We want to see buffers. I'm going to assume for a moment that people can walk up to a distance of 1 mile each way to get to their assigned pod location. So here we see these buffers around the pods. So it's still calculating. Give it just another moment here. There we go, vulnerability calculated. So we could see that although there's 137,000 households in this 49 county region that don't have a car, only 86,000 of them don't have a car and live further than a mile from their assigned pod location. So here we can change this from 1 mile to 2 miles to half a mile, or we could do it in kilometers if you prefer the metric system. So that is a quick review of vulnerability analysis and replan. Now, once you've built your pod plans, you have your vulnerability analysis done, you have all of your dispensing lanes done, your catchment areas created. That's where we are here. Then you really need to go and say, well, how do I get the medical countermeasures to all these pod locations in the first place? Well, that's RSS to pod routing. So what we need to do is we need to declare an RSS facility somewhere here in this region. So I'm going to go into facilities and select RSS. I'm going to add RSS. So for this example, I'm going to choose UNT Discovery Park campus at 3940 North Elm Street in Denton. I'll hit save. And when I go to the map, I go to facilities, I'll see an RSS option. And there's my RSS right there, as I would expect. Okay. So I'm going to kick this off and then I'll tell you what it's doing, because it will take a moment. So most RSS to pod routing solutions that are out there are going to ask you a handful of things. Of course, they're going to ask you where the pod locations are, which we have here in replan already because that's what we use to build these plans. How many pallets need to be dropped off at each pod, which we have because in replan already, because we know a mapping of populations to these pods. Where the RSS location or locations are, which I just entered a single RSS location for this example, but we could have entered multiple if we'd have liked. And then how many hours do we have to complete distribution? Well, in this case, you'll notice I have this slider and I drug it from 4 on one side to 15 on the other. So rather than specifying a number of hours, replan allows you to specify a time range. And what it's going to do is it's going to come back with options that will allow you as the planner to select basically the sweet spot where you have enough resources in terms of security escorts and trucks, delivery vehicles, to be able to complete dispensing within the shortest amount of time possible. For example, if you were planning on using 8 hours to complete MCM distribution, replan could potentially tell you that for 3 or 4 more trucks you can do it in 5. Well, what happens to those 3 hours that you've saved? You can either pretend they didn't exist and use them as slack for when something goes wrong, or since that hard deadline mandated by City's Readiness Initiative of 48 hours is sitting out in the future, You may have only had 36 hours for dispensing before, but now you've gained another 3. So moving from 36 hours to 39 for dispensing means, well, to serve the same population, you don't need to dispense to as many people per hour. If you don't need to dispense to as many people per hour, that means you don't need as many dispensing lanes in each pod. If you don't need as many dispensing lanes, that means you don't need as many people. If you don't need as many people, that means you've cut down on the number of volunteers you require. And volunteers are likely going to be one of the largest resource constraints that you're going to have. So really what Replan is letting you do is it's letting you trade trucks and security escorts for volunteers. Now, another piece of information that most routing tools ask you is if there are multiple RSS sites, which RSS site does each truck start at? Which then of course implies that you have to specify how many delivery vehicles there are. Replan doesn't ask for any of that. I could have had any number of RSS sites input here, and Replan will just figure out which one to use based on the algorithms that are underneath this system. On top of that, since we're not looking at just one time frame, but here we're looking at 4 hours versus 5 versus 6 versus all the way up to 11, 12, 13, 14, 15 hours, we don't need to specify a number of delivery vehicles, number of trucks. Replan will tell us how many are required. Now, other solutions that are out there, you basically have to guess at this to make decisions regarding these parameters. You have to guess how many trucks would be needed given a certain amount of time. If you guess wrong, then you spend a lot of time building routes because you're waiting for the software to build routes, and then the results you get back could potentially say, well, here's all your routes, but we didn't reach these particular pods, which is of course unacceptable because you can't have a pod operate until it's been delivered its medical countermeasures. Therefore, you basically have to make another guess and potentially another guess. But if you guess too high in terms of the number of trucks, then you could have an inefficient plan where you have way more trucks on the road, which means potentially way more security escorts than you actually need. So hopefully this will come back fairly soon. Given the size of this particular plan, this could take several minutes to execute. Now, another thing while this is executing that I want to mention is that although when watching this video it may seem like it's taking a while, in reality if this takes 5 minutes to execute, that's really not that long compared to other solutions that are out there that can take much longer potentially for even smaller response plans in this 49 county region. If the day comes when you have to actually activate these response plans, if you have 200 and something different pods across your region, you're bound to have at least a handful that can't be activated during the time frame in which you need to activate them. Well, that would mean you need to either choose auxiliary pod sites, or you need to basically just not include those pod locations, and the surrounding pod locations would have to more or less pick up the slack. Either way, you're going to need to repartition so that all your populations are assigned to the closest pod. Now, the moment you repartition, you're going to change the number of people that are going to each pod. Changing the number of people changes the number of pallets. Changing the number of pallets at a handful of pods means that all of the route calculations you've done before, they're not necessarily valid anymore. So you'll need to be able to quickly go in and recalculate these routes. So Replan, by running much more quickly, by being able to execute this type of analysis much more quickly than many other packages out there, is ideal for being able to use during this just-in-time planning phase, where you're doing last-minute route calculations based on information during activation that you couldn't have known ahead of time. Okay, so here we can see it's returned. I think it took around 7 minutes to execute, which really isn't bad, considering how large this plan is. Now, it notes that hours that are not possible have been removed. Well, I basically said from 4 hours up to 15. In other words, we could see that there's no bar for 4 hours. So there was no way to complete this distribution within 4 hours, given this RSS and these pods and the number of pallets that each pod needed. Now let's go back to what I was talking about before. If I was planning on maybe doing 8 hours, you could see it takes 55 routes. But for one more route, I can do it in 7. For 3 more routes, I can do it in 6. For 5 hours, it jumps all the way up to 68. So we could really see that, well, if I can afford 13 more routes, maybe I'll do 5 hours. But otherwise, it would almost be hard to justify not saving 2 hours by adding 3 more routes. Now those results that correspond to these bars in this bar chart are down below. So you can see for each one of these bars, we have in the drop-down menu 5, 6, 7, all the way up to 15. So if I'm on 5, it's showing me the routes for completing distribution in 5 hours. Here's just basically a shorthand description of what's happening. If I click on this little eye, it shows me the actual delivery order with addresses and everything. Of course, there's a loading order as well that has to be in the reverse of the delivery order, because you always want to load the first stop last, so that it's at the back of the truck. That way you don't need to shuffle around pallets. Okay, now I could see if I go to 6 hours, I'm going to have a different set of routes. If I go to 7 hours, I got 5 hours, 6 hours, 7 hours. When we get to a certain point, this 8, 9, they really had the same routes because they both took 55. But let's say I was going to pick 6 hours. I can click on download loading and unloading lists, which downloads a zip file that now I can open up that zip file. Here it is. And I've got traveling sequence. So basically for each route, it gives me a PDF file where we started this example RSS as I entered it. Then the first stop is Fossil Ridge High School. We drop off 4 pallets. Here's the address, GPS coordinates. Second stop, Haltom High School, so on and so forth. 3 pallets. We have that for each one of these routes. And then of course we also have the loading sequence, which is the same thing as I mentioned before as the traveling sequence, but in reverse order. Essentially what Replan is doing here is it creates all these PDF files that you can just print them out, and you hand these to the logistics folks at your RSS, and you hand these to your delivery drivers and security escorts. And that is our demonstration of Replan on a large 49 county region in north central Texas for building plans for distributing and dispensing antibiotics for aerosolized anthrax. Thank you.